I
Okay.
hope you are able to see my screen.
Yes, we are able to view a screen. Yeah.
Okay. First of all, thank you everyone for waiting for me for the last 15 minutes. I sincerely apologize for being late for this session. I had some emergency, but was somehow able to make it to the session. Till like 1 hour back, I wasn't sure whether I will be able to make it to this session or not. So for all of you who are still in this call and attending this session, I want to thank each and every single one of you for taking out time and then waiting for me. I really appreciate it. Thank you. Um, Now, before I start, I also want to thank you, Rohit, for being the moderator of this group, and I hope all the organizers did a great job in organizing this security summit. And I heard from my peers that the summit has been going quite good. So we have got very good feedback so far, and we have a lot of good sessions. And there are a couple of sessions to follow after this. So I think all the attendees might have a great day of learning, and it might be or it should be very beneficial for all of you. That's the idea. Having said that, let me start with my session. So my name is Mohit Chabra. I work as a cloud operations manager in Configure Germany. And apart from that, I'm also Microsoft Azure MVP from last 5 years. So I basically works on Microsoft Azure day in and day out. So anything related to Azure, I am the guy that is like looking into it or working on it or interested to talk about it. So be it security or the infrastructure or the DevOps or the architecture. So I don't code, but I do the architecture around stuff. Currently, I lead the whole cloud department in my company, and we have our team spread across the different regions. We have people in India, UK, US, Europe, Germany means in Europe. In Europe, we have in Germany, Denmark as well. So my team is spread across the different locations across the world. My job is to make sure that we deliver the good performance on the softwares and also securing. And one of the way we secure our system is we have a SQL database and we wanted to secure it. And what we did is this session is all about. So sharing my experiences, the challenges that we had, and how did we try to resolve it. So to start with, all of you know that this session is about blockchain. So to start with, what is blockchain? The moment I say blockchain and people hear blockchain, the first thing that comes to their mind is Bitcoin. And I hope that most of you, all of you have heard this term by now. If not, maybe you're living in a cave. But the Bitcoin craze is quite high across the world. But Bitcoin is an implementation of blockchain. So the whole concept of blockchain came in 2008 when Satoshi Nakamoto, who's the inventor of Bitcoin, developed a technology called blockchain. But the implementation of the technology does not basically implies just to the cryptocurrencies like Bitcoin. So the as we understood that we tried to understood the concept of Bitcoin, people understood the technology underneath it, and then it was very clear that this technology is much bigger than just a cryptocurrency. So the whole technology can be used for multiple purposes, and there are different implementations or the benefits that we can get out of this technology in itself. So Bitcoin is blockchain, but blockchain is not just Bitcoin. So Bitcoin is just one implementation of blockchain. Having said that, what is blockchain then? So blockchain is basically a technology which allows you to do a transition from to basically do a transition in a way that all the transition are stored in a block, and these blocks are mined on multiple servers. That means that there is no centralized And this is a very crucial word to understand the whole concepts of blockchain and also the whole concept of what we are going to do today. The whole concept of blockchain, that in blockchain, there is no single source of truth. The whole concept or the whole database, the whole transition database, which is we call it a ledger. The ledger is not on a single node. It's on multiple nodes across the world. So when we basically talk about blockchain in general, for example, and let's take an example of Bitcoin as well. Like you might have heard the concept of Bitcoin mining. So what is happening in the Bitcoin mining is you're approving a transaction. You are also trying to resolve or basically solve uh, a mathematical program alongside it. And if you're able to resolve it, you would get some Bitcoin as a benefit as a part of the mining process. But because it's happening on a multiple nodes at the same time, so there is no centralization around it. The decentralization that we have as a whole concept in the Bitcoin is basically one of the fundamentals of blockchain. That once anything that goes to a blockchain is immutable. That means it cannot be changed. So you cannot forge any data. There is cannot be any data manipulation once it goes to blockchain. And why does that happen? Because of a very simple concept that the ledger is spreaded across multiple locations. So it's very difficult to hack different databases or different versions or different replicas, as you can call it, different replica of this database, the blockchain database, and make changes to it. So you need to basically change it 51% of nodes, which is very hard when you're in a decentralized world. So this is going to be pure decentralized. So that's the idea. But the another concept that you need to understand is when there is a transition, the transition is stored in something called as block. And then once that block is filled, a new block is created and the old block is pointed to the new block. And hence the word or the name blockchain, blockchain. So we are basically building a chain of blocks in the transitions. So in your normal SQL database, you store it in the form of rows and columns, right? In NoSQL, you store it in depends on the kind of NoSQL database, but it could be key value pair, it could be JSON, it could be NoSQL tables, whatsoever, right? It should be a document-based database like Cosmos DB or MongoDB, right? So those kind of stuff. So instead, what we have in blockchain, it's everything is stored in a block, and then with the help of this block, when this is put, a link is created. I hope you all understand the whole concept of linked list in the data structure. So you point to the another node that's the same concept over here, that you point to the next block of data, and that's how a chain is built. And with this chain, the data that goes to the blockchain is fixed, so you cannot make any changes to it. So what's the benefit? So we talk about this decentralization, and we also talk about this immutability of the data, right? That data cannot be changed. Sorry. Because of this whole concept, the data cannot be forged, the data cannot be changed. There is a lot of trust that comes to these applications. That the data that we are looking is never been manipulated, and its data is always going to be in the same state. It's immutable. But also blockchain people like companies are using this blockchain for a lot of auditing purposes as well. When I say auditing, that means typical classic auditing of your setups. But of course, if you put anything on the blockchain, it cannot be manipulated, right? So I'm reiterating that part again and again to make sure that you guys understand that. Um, so the audit blocks also goes to the blockchain, and hence the audit is by definition of it, we can say that okay, it's fixed, and whatever goes to the audit block, it's basically fixed. So the whole process till now has been very slow, and it's of course time consuming and hence costly, right? So you require a lot of manpower to do it, and resources aren't cheap anymore, right? So the man labor is always expensive than than the computation in the world, right? So we want to use more of servers time, more of the computation around it instead of using the man hours around it. We used to when I was a child, we used to see a lot of department used to use the pen and papers and then maintain registers or maintain registers over there, and it was such a nightmare, right? I cannot think about doing that right now because it's very time consuming, it's not efficient, and that's what people have understood as well in the companies that for the audits and stuff as well, like because we need that trust, it's better to go into a technology which is a faster, and B, it reduces risk, and C, that it's more cost efficient. Like it's a win-win situation for the companies, right? So talking about blockchain itself, like blockchain market has been exploding. I hope that you guys have heard about blockchain by now, and also like cryptocurrencies in general, for example. Um, Previously, when I started looking into the world of blockchain and cryptocurrencies in general, the market that we had around Bitcoin was like fairly low. People used to use it when I bought my first Bitcoin. People used to only use it for drugs or basically weapons. It was mostly used in the dark web, and we didn't had the same kind of exchanges or the infrastructure that we have right now. So since then and now, and the infrastructure has grown, the digital infrastructure has been built, and the whole concepts of blockchain has been evolved as well. So we have identified that there are much more use cases of blockchain than just crypto, and then our companies have investing heavily on the blockchain, their blockchain journey as well. So this was in the 2020. There was an article which says that it's going to be at 21 billion. The latest one that I saw again was saying that could be around 50 billion as well. So the market is exploding at this moment around blockchain. But there's always a but, right? So if it's so good, everything is so fancy, market is exploding, should we jump onto it and we use it in our project? The answer is maybe. So it's not a Swiss knife. So blockchain in general is very good, but it's not a one-stop solution for all your needs. You need to understand when it makes sense for you to basically use blockchain and when it doesn't. And if you see this article simply says that 90% of the blockchain projects are misaligned because it does not need the whole concept of decentralization that we have in blockchain. They just need the trust that blockchain is bringing to us, but it does not need the complexities of blockchain. What does it mean? So if you see over here, the transitions basically happen on nodes, on individual nodes, and this is our user. So all in a decentralized world, what we need to happen is that the transition needs to be validated by X amount of nodes for this transition to be approved. So this whole concept, it takes sort of time. It's slow. The whole concept in the blockchain itself is slow from a technical point of view. Um, I don't know if you guys have used cryptos, but sending Ethereum or block or Bitcoin over from one wallet to another wallet takes sort of time because that's a transition that is happening. And with this transition, there is a lot of governance policies based on cryptos around it. Like every crypto has its own policy on how many nodes has to accept this transition first to say that this transition is successful. They could, I think Ethereum has like 11, if I'm not wrong. And once this is done, then only it says that the transition is successful. So those governance rule you can by definition you can basically control it in your own implementation of blockchain. But the overall idea of this notes notes has to basically approve this is the challenge. And of course, it's not super fast because of this decentralization. 10 different nodes has to approve this request and a transition, then this transition is successful. Until then, it's been stuck, right? So it takes a lot of time. It's not the fastest solution. Like, for example, like if I just talk, I'm again jumping onto the concept of crypto because I'm imagining right now that most of you knows about crypto. So if you transfer the money from UPI, it's goes immediately. But if you transfer money from the cryptocurrencies, um, it's much more fast. It's not that fast. If it's on actually on blockchain, because there's a lot of concept around tokens and token could be faster, but the if it's actually on a blockchain and the transitions are happening on a blockchain, then it's quite slow. One of the another thing that we have seen in a lot of the projects that I have interacted with people and in general as well, that people put everything on blockchain, but then they also build something else, which we call it as off chain, because the data that we have on blockchain, we don't have great analytics tools as of now. Probably, like of course, it's a growing field. So in the future, we might have much more much more cheaper and better solutions out there. But as of today, it's still a challenge that people have to copy this data into an off chain, maybe in a SQL, and then um, or any other, like it does not have to be a SQL, but the whole concept of off-chain is to copy the data and build a copy of it and then put the analytics on top of that. And that's a challenge because with this, we don't have any data integrity of off-chain. The whole concept that we were, or the whole benefit that we were aiming this for was the data integrity in the first place, right? So this is a challenge, uh, always a challenge that if you're copying it, then do we actually need blockchain? Because if you end up copying the data over here and you're building analytics over here, this part is inevitable, but the SQL part can again be modified. So it's not inevitable, right? So it's not false proof. So the the whole idea is the whole summary of this is basically that blockchain is in general is a very good solution, but is it a one-stop solution for everything? The answer is no. It might be an overkill for a lot of your scenarios. So you have to identify that whether the things that you want to achieve can be achieved with a centralized solution without having the decentralization of blockchain. But the whole concept of blockchain remains same. Uh, then the answer is don't go for blockchain. There are better or more efficient solutions out there. One of the solution that we are going to discuss today is something called Azure SQL Database Ledger. And it's basically a functionality of SQL that is available in both on-premises and cloud versions of it. So if you're hosting it in a virtual machine, or if you're hosting it in your on-premises, or if you're using SQL Azure, it's available in all of them. Um, the idea is the idea around this is that and it also happens in the blockchain that we create a hash. We basically cryptographically we create a hash and then store those hashes to basically make sure that there is the immutability in the data. Similarly, in the SQL database ledger, as the word says that it's a ledger, um, the idea is that we create a hash of the data periodically. So we automatically create these hashes, put these hashes, and then basically use these hashes in a way that we can identify whether the data has been manipulated or not. I think all of you understand the concept of hashing. So the basically, if you make any changes into the source and then create a hash, the output can never be the same, right? It has to be an identical input to get the identical output. So I'm gonna jump a bit more onto that, but I am assuming that I don't have to go deep into the whole concept of cryptography because we are in a security summit and that's like quite basic. But of course, if you don't understand it in the end, we can ask me again and I will be happy to do a much deeper explanation to you. Um, there are different type of ledgers. Now there are two main types of ledger tables: the updatable ledger tables and the append only ledger tables. So as a name itself is like quite explanatory that this updatable ledger tables are the standard tables, but it comes with something called a history table, and it allows you to make changes into the application in the table. That means you can make an update, you can delete this, you can do whatever you want. So it allows you to make changes in the actual table, which is not possible in the append only. So I'm going to come to the append only table, but the idea is that if you see over here that when you have a SQL, we have this table by default. If you make this as on, then there is a history table which is created. Then on a periodical time, we are going to create a hash of it, this hash of this table, and put it in a block. Once this block is filled, we create basically another block and then another block. So it's going to be a periodical effort. And then whenever this block is filled, we are going to copy this block to an external storage. So this external storage, we have like two different options. It could be a storage account in Azure, or it could be a blockchain hosted by you or in Azure as well. So the whole idea is that in the appendable circuit, we basically have or updatable ledger, we basically creates a history table. This history table has all the records of it, whatever changes, whatever data manipulation that we have done in this. So if we identify that if there has been a data breach or someone basically have changed or manipulated the data, we'll be able to identify and audit it with the help of this history table. If you're not able to understand how does it look like, I'm going to do a demo so that will make you understand the whole concept quite well, hopefully. But the overall idea is that the actual data is here and the history data contains all the audit logs around it, whatever changes we have made to it. And then we also generate a ledger view, which we basically gives us the overall view on how does the data look like and what changes have gone into the table. And also the whole concept of cryptography around it, that we create the hashes, put these hashes in these blocks, and then copy the data in a external storage. Why external storage? Because if someone hacks and get into this SQL, they still don't have access to this storage. And then there are another concept of how should we verify whether this storage has not been updated. So I'm going to talk about that part later. But the overall idea or the architecture of this setup is that keep creating hash, put it in the blockchain, put this blockchain out. That we can so that we have a trustable location where we can verify it later whether this hashes has been updated or not. So that's the idea overall in the updatable. But in the append only, what happens is we only have a table over here. There is no history table because the history is not needed because all the data that we need is uh, is basically is part of this append only table itself. So I have a beautiful animation to showcase it, but I just in the last 5 minutes I basically copied it and didn't test it my PPT. So I will make sure that the PPT that I share with you guys have this beautiful animations around this, so that you are able to understand these concepts quite well. But the overall idea is that if you use this, then in the append only, there would be no history table, no ledger tables. And because it does not make sense, the append only table says that, okay, the data can only be appended. So there's no point of having a history table because all the data that ever existed is part of this append only table itself. So we don't need a history table around it. So talking about the storage, we have a couple of options like we can store it in a storage account in a blob storage. or we can basically use Azure Confidential Ledger, but we can also use your own blockchain. If you have on running or your blockchain running in on premises or on the cloud anywhere, you can point it to that as well. That's also possible. The overall difference is that you can put it in a storage. This is more managed by Microsoft and it's more of a Microsoft technology, whereas the Azure Confidential Ledger is built on top of the open source framework for Ledger. Also, this is more Azure friendly, like people who have been using Azure knows more about storage. This is also from the Azure, but this is more for the open source or more for the blockchain community. So you can go through the different um, differences and then take your decisions accordingly. I'm not gonna go through all of them just for the sake of time. Uh, and I'm not gonna go with a lot of PowerPoints any further and jump on a demo instead. I think that will be much more crisp for all of you to listen to. Um, so what I'm gonna do is I'm gonna create a SQL database. ISS ICSS T22 demo. Quite okay for till now, so nothing fancy. I'm just creating a server and then I don't need an investment pool. It's a development environment. I don't want to put a production workload to it just for the demo purposes anyhow. Um, so I'm going to say add client IP, quite basic till now. But till now, this is where the change is when you're creating a new resource. So you basically have this option. Let me go back. So we have this option of ledger. And Wedge cryptography verifies the integrity of data and detects any tampering that might have occurred. So what is Wedge? We know that now. But how do we configure Wedge? Is we say that okay, we enable it for the all the tables, and then here we have the option that whether you want to put it in a confidential ledger, which is 70 view, or you want to put it in a storage account. So I would say storage. It's cheaper. Storage is anyhow cheaper. I will go there. I don't need any data source, nothing. So I'm just gonna go ahead and wait for this to create and click on create. So there are two options. I will just create and then wait for the deployment, or I will use the second option like a cookie show. If you guys have followed the cookie show previously, that what happens in a cookie show is that they put pizza in the oven and next second they put out the pizza and then said, okay, our pizza is ready. So you don't have to wait for the whole pizza to be baked. And that's what we have done over here. That I already have created a server and the same way that we have, I already have created a server in the database. And what I need to do is just go over there and showcase it to you. So I am going to add my current IP to make sure that I am able to access that database from my SQL Server Management Studio. So this is my database. I already have some tables in it if it loads. So So I'm just selecting the data right now to show you what kind of data I have in over here. But before I go into data, I want to show you a couple of things, which is quite useful and crucial. Um, you see, the moment this table is created, there is a history table created for it automatically. And similarly, a view is also created. Remember the diagram that I was talking about that is not animated right now. But this was the concept that we created the history table for it automatically and also the view around it automatically. So you don't have to create it on your own. It's on the updatable ledger table. And this is why it's automatically created. What is the benefit of it? We'll look into it. So I am gonna select this guy. Right. So if you see, I selected the table itself, and the data says there are three records: last name, first name, the current parents of it. There is also a ledger start transition ID. This is going to the blockchain. And if I go to the view now, you see there have been few different operations that has happened in this table. So first of all, that's a difference. What I'm going to do is give you a new query. Let me open some of the queries that I have it saved. I think I should just open the files individually. That's easier. 1, 2, 3, 4. Okay. So I have 4. So I see the full name of Yogesh. So I'm gonna use you Yogesh as an example, if you don't mind. So I have a very basic account table which has this customer ID, last name, first name, and the balance of it. Very basic, quite basic. I don't think I have to explain that to anyone over here. Uh, I can put the amount. It's 5,000 to start with. Okay, I think we already have. Perfect. So if I go to the view again, so uh, over here, customer ID 4, 5,000, ledger, what is the new transition ID, and it's been inserted. You see the command. If I run the actual table, this is my this is my updatable view so that I can basically revert to it on whatever the changes that has been done in this table, whether it's an insert or a delete, because there would be two kind of operations only, insert or delete. How do we say that? We say that because if you come over here and say Yogesh, I just gave him 5,000, which is too less. He is spending his Saturday evening here with us, so he deserves to make much more money probably, right? So we know the ID is 5 and customer ID is 5 as well. So let's give him some more money. I think he's gonna be a bit more rich now, hopefully. So now if I run this again, you see the difference over here. So we have one record over here, the number 4, which is saying that there is a new insert and the old one has been deleted, right? So this is how a data manipulation queries have been visible in this view, that the old record has been deleted and the new has been created, but you can still see them over here as a part of this view. So if you are in the process of audit, you will be able to identify if someone has been able to get into your database, that what changes they have made. So you can tell if you can, I know it's going to be a difficult task, but you can actually revert back to the individual changes, because sometimes what we say is do PITR, but that's not always the right approach, because then you also lose all the data that you have generated in with the actual data that you have generated from the last time that you wanted to restore to. So here you can identify what data has been manipulated, if it has been manipulated, um, to start with.
Here, just a reminder, last 10 minutes are remaining.
So thank you. Thanks for it. That should be enough, hopefully. Um, so you have all that in this view itself. So if you make any changes, you will be able to identify it over here. But the next thing or the next event that comes is basically that we were talking. This is only kind of a history in the database. Like we were talking about having this blockchain and storing these blocks in an external storage. We discuss about this whole concept of storage account, ACL, putting it in the blockchain. But where is that? Where does that comes out? So that's a very big question. So what we do is, as a part of this whole creation of the database itself, right? We pointed it to that storage account. Another option is that if you're not creating a new resource, you can also enable the ledger in your tables itself by using this command. So you say that create table, or basically update table with these commands, like say system versioning as on and ledger as on. So if you run it on your tables that you want to run it against, and you will be able to basically make them the ledger enabled as well. The one thing that is very important for you to understand, that once you enable the ledger, you cannot disable it. And I think you all of you understands why, because the system does not know whether it's you, the right person, the right admin, disabling it, or it's actually a hacker who has the asset and try to disable it now. So mm, distinguishing between an actual user versus a hacker who has access to the system somehow is very challenging. So if you enable it once, it's going to stay there for the rest of your life. So it has to be a conscious decision. You have to go through all the pros and cons of it, and whether you need it or not, if you're enabling it for your customer subscriptions or production systems. Um, Now the next thing is the verification. Like we talk about that periodically, that we are gonna keep taking the snapshot, or basically keep creating the hash of the database and then put it in the blockchain. Um, with this, basically, what happens is that the hashes are going and then storing in this blockchain, right? Now we have to create the hash right now and see whether it matches in the blockchain or not. So we have to keep on verifying it. We are putting it as a verification method, right? But we also need some method to verify it, whether the hash also matches it or not, right? So we have this SP from Microsoft themselves. So I have, this is not something that I have created. It's just copy pasted from the Microsoft documentation. We basically run this SP over there, and then see the digest location. For us, the digest location was storage account. So what we are going to do is run it against this digest location, and if I run it over here, I get three results. So the location of the digest, so you can see that it's stored in a block container, and how many blocks has been verified. The last one was like the seventh one, and also this small result, which is quite useful, saying that the ledger verification is successful. Um, so if this does not say successful, that means there is an issue that the data does not match in the blockchain. The hashes does not match in the blockchain. Or there could be another thing, like the whether if let's say we have already been compromised and they have the asset, they can also change the location of this digest, right? Because that's possible. But if they change it, then here in the digest location, if you see, I'm not sure if you can, but this is basically an array. The output of this is basically an array, so it will show you the all the location that has been used and gives you the latest one that okay, this is the latest one, this but initially it was this, then it was changed to this, then it was changed to X, then Y, then Z. So you can identify that someone has changed this digest location as well, because there's no point of verifying it to something, but if the verification source has been changed itself, right? So we also have to be on top of it as well. So what we do is two things: verify whether the digest is correct or not. Check, of course, we don't do verification block ID because it's okay. This is for your auditing purpose. And then the most important thing is whether this result is coming out to be successful or not. So that's about the demo. I'm gonna jump back to the PPT.
Yeah, last 5 minutes remaining.
Yes, yes. So what is the scenarios? The scenarios that we use it to for streamlining the auditing process. If we have multi-party business processes where you need the trust, but you don't need the whole concept of decentralization. Or if you want to use it for off-chain, that's where we can use these. I have a simple slide of dealing you a different scenarios. I'm not gonna go through it in the interest of time. But the whole idea of this slide is because I'm going to share this PPT with the organizers and it will reach out to all of you, is that in which scenarios you're going to use the SQL ledger versus which blockchain. So you will get almost all of the stuff that we need in the blockchain, but you cannot use it for tokenizations. That means you cannot create cryptocurrencies out of these, or you will not have a decentralized consciousness. So it's a pure centralized because you have been managing it. It's not the whole different people managing it for you, right? Across the different nodes. So it's going to be a centralized solution, and it's the whole cryptocurrency concept does not come into the picture. Having said that, I just want to announce that if you have a DevOps engineer or an Azure administrator, and if you're interested in security, I might have an interesting job for you. So please reach out to me after this session and we can have this conversation. You can reach out to me on LinkedIn and we can start that conversation around, because we are looking for some talented enthusiast people. And I think the people who are spending their Saturdays in learning and upskilling themselves, there is no one better than them. If you ask me, that's my personal opinion. So having said that, I am now open for questions and answer for next couple of minutes. We have any questions?
Guys, please unmute yourself and you can ask the questions.